Hey, how's it going? It's Mr. Farrell here. Let's go ahead and work on another physics problem. Today we're dealing with the work equation, okay? But in dealing with the work equation, we are actually focusing on how to use it to calculate force, okay? So you can use the work equation and just rearrange it in order to calculate force. That's what we're gonna do today. All right, so we've got a problem here. It says Austin does 423 joules of work over a displacement of 17 meters. How much force did Austin exert on the object? All right, the object that he did work on. Okay, so let's go ahead and write out the ICE method. We'll start this problem just like we started the other problem. All right, and the first step of the ICE method is to identify. So here we want to identify all of the measurements in the problem. Remember, a measurement is just a number and its units. So when we do this problem, we're going to identify 423 joules, okay, 17 meters, and that actually looks like it's all the measurements in the problem. Now, the other thing we want to do in our identify step is we want to identify if we're being asked a question. So when we look over this problem, we see that our question is actually asked right here, okay? Now, it's not important to know what our question is being asked about just yet. We just want to make sure and see, are we being asked about something in the problem? So let's go ahead and write down our measurements and write down that we're being asked a question. So 423 joules was one measurement, 17 meters was the other measurement, and we are being asked a question. So we just write a question mark there. All right? Now, as we're trying to solve this problem, we are going to go to our next step of the ICE method, which is to categorize. So we need to categorize all of these measurements as a variable, okay? Including our question, what variable represents the question that they're asking us in this problem or that we're being asked? So 423 joules. This one's interesting because there are so many things that can be a joule, right? A joule can be kinetic energy. A joule could be work. A joule could be thermal energy, right? All energy is measured in joules. So we need to figure out what variable is this form of energy telling us about. Now, there are a couple ways to do that, but mostly just going back to our problem. So our problem tells us that Austin does 423 joules of work, okay? So that we know that this is energy that is being used to do something. It's not just energy of motion. It's not energy that's being used to change the temperature of something. It is energy that's being used to move something or do work. So we're going to write this as W for work. All right? Sweet. So we've got our 423 joules categorized. Now we go over to 17 meters. Okay? So we know that meters is a unit of displacement, right? But this could also be position, right? Because a position would be measured in meters as well. So what we're going to do now is we're going to measure or figure out whether this is position or displacement. So when we look at this problem here, it tells us that this work is done over a displacement of 17 meters. So from that, we know that this is displacement as well. So we're going to go ahead and write that down. So delta x is the variable we use to represent displacement. All right, it's not just a position that this object is located at. It's actually a displacement that this object has been moved, a distance that this object has been moved. And then we know that because this is positive, that displacement is telling us that it's either moving north or south, whatever the positive direction is in this problem, that is the displacement or the direction it's moving, as well as that distance it has traveled, okay? And our last one is our question. So how much force did Austin exert on the object? All right, so we know that this question is asking us about force, okay? And so we're actually going to go ahead and write that down, and we represent force with the variable F, all right? So now we've categorized all of our measurements. Now it's time to go to the equate step where we choose our equation that's going to be used to solve this problem. Now we see each of these variables here. We want to find an equation that has those variables in it, all right? Because we don't want to use an equation with none of those variables to try to solve this problem. We want to use the equation that has what we know and what we're looking for, all right? So the equation for work is actually W equals F times delta X. So work equals force times displacement, all right? That equation has all of these variables in it, and so it works out great. All right, so we're going to go ahead and plug in our measurements into the work equation and begin to solve it. So work is 423 joules. All right, that equals force times our displacement, which is 17 meters. Okay, great. Now we've plugged in our measurements, and we can go ahead and begin to solve this problem. So force is what we're looking for. So we need to isolate force. We need to get it by itself. So in this evaluate step, we're going to begin to solve or try to isolate our force. Now, force is currently being connected to 17 meters through multiplication. So in order to separate them, we need to do the opposite of what's holding them together. So instead of using the multiplication operation, we're going to use division to pull these things apart. So we're going to divide by 17 meters, and whatever we do to one side of the equation, we have to do to the other side of the equation. So we're going to divide both sides by 17 meters. Now, what that does is we have 17 meters in the numerator. That cancels out with the 17 meters in the denominator, and we are indeed left with F. All right? Now, I don't have too much space on my board, so I'm going to go ahead and erase and rewrite this, and we're going to keep on solving. All right? So we've got 423 joules of work divided by 17 meters for our displacement, and that equals our force. All right? Now, we can go ahead and just divide these numbers. All right, so 423 divided by 17 is going to give us 24.88. All right, 24.88. And that's going to be our force. Now we need units to go with our number, okay? Now here we have joules up top and meters on the bottom. So we just keep that, joules divided by meters, just like we did 423 divided by 17. So we're going to go ahead and write joules divided by meters here. Now, 24.88 joules over meters is equal to the force. But there's a unit that we can use that we more commonly associate with force, and that is the unit of newtons. Whenever you see a joule divided by a meter, a joule per meter, that is a measurement, or that can be rewritten, that unit can be rewritten as a newton. So whenever you see this here, you can actually cancel that out and rewrite it as N, okay, for Newton. So let's actually go ahead and just erase this so we can write it more cleanly. All right, we're going to go ahead and put N there for 24.88 newtons of force, okay? So now let's take a pause just to make sure we understand what this problem is telling us. It is saying that if Austin is trying to move whatever object this is 17 meters, I've got to apply a force of 24.88 newtons for those 17 meters. And I'm going to end up using, or I'm going to end up exerting 423 joules, or doing 423 joules of work, rather, okay? So if I were to use this force to push this object 17 meters, then I would be doing 423 joules of work. Now, I don't know how much the object weighs. I might have been able to move the object without using this much force. But if I use that much force, I'm moving this object maybe faster, all right? Maybe I could be moving it even faster. And that is causing me to do more work. Whatever it is, right? This is the amount of force that I chose to apply. And because I'm using that force, I'm going to end up doing that much work. It's going to take that much energy in the motion that's taking place. All right? Sweet. So I hope this helps you walk through work problems in the future, and have a good one.